Hi, this is Team A. I'm Ali Yang. My teammates are Xiao Gong and Xinyao Li. Our research topic is on Yelp's text sentiment analytics. Let's have a project high-level overview first. On the left-hand side is a screenshot of the Sushi Fuku. You can see most of the reviews are either neutral or negative, and the overall star is only 3. However, on the right-hand side, most of the tips are quite positive. That leads to our business statement. We hypothesize that review sentiment is not a complete picture of the overall user sentiment. There's an opportunity lies in the tips data, which is only available on a smart device. Tips are usually short, composed of a few words, while reviews are usually long, composed of few sentences. Our proposed solution is to train the review data with the star as the label and use the model to predict the tip sentiments, assuming that the review and the tip have similar text structure and vocabulary. Lastly, we will compare the review and the tip sentiments and see if there's any significant difference. We used the round 7 of Yelp data challenge. The data spans for 10 countries in the past few years. We have 4 major steps. Instead of going through them in detail, I'm going to show you our results and analysis with more charts, and that will better vividly show our processes. We pre-process our review text by removing the stemmings, the white spaces, and the traditional English stop words. We also identify some particular stop words in our corpus, such as restaurants and Pittsburgh, and remove them. At this stage, we are left with roughly 600 features. Next, we conducted the feature selection using the R package F selector. We achieved a minimized error rate when the observed variables is 81. On the right-hand side, you can see the features ranked in accordance to their importance. In addition to the text features, we also added in features such as review average star, review count, user fans. We applied 3 algorithms to the full dataset and the selected feature data: naive Bayes, SVM, and random forest. We identify random forest as the best performing algorithm. Unfortunately, the selected features did not achieve a significant boost in terms of performance. The performance are quite similar. However, the selected features do win us some time. Therefore, in our future classified testing phase, we will continue to use the 81 selected features, which will have roughly the same performance as the baseline features. In order to determine the ideal number of trees for the random forest, we conducted a cross-validation. We identified 450 trees in the full features and 160 trees for the selected features. As before mentioned, we'll use the selected features and we'll use the 160 trees in our testing phase. These are the ROC curves for all of our 5 classes. Class 1 of 5 has the highest AUC value, about 0.8 and 0.7. Class 2, 3, 4 have AUC value of close to 0.7. Overall, we think the performance is from fair to satisfying depending on ROC values. Lastly, we use the train model to predict the tip sentiments. By comparing the 2 charts, we can see that the sentiments are quite different. In review sentiments, half the sentiment are from 4 to 5 and half are from 3 to 4. In tip sentiments, majority of the sentiments are from 4 to 5. We also conducted a t-test of the mean scores from review score and tip score. Out of the 17 communal business ideas from review and the tips, 11 out of them have significantly different sentiment average scores. At the same time, we also identify some factors that will negatively impact our results, such as the multi-class prediction, subjectivity in people's reviews, the diverse restaurant and customers, which will make our data heterogeneous. Some solutions, such as only train positive and negative sentiments, train classifiers for each of the star, focus on important stars such as star 5, and only focusing on particular type of restaurants. That concludes our research. Thank you, and we're looking forward to any constructive feedback.